Hey guys, now in this video what we're going to see is we'll check if a number is prime number or not in optimal way. Okay, so basically understand what is prime number. Prime number is nothing but a number which completely divisible by 1 and itself. For example, if n is equals to 5, then this number 5 should be divisible exactly by 1, completely divisible by 1, and it should be divisible it should completely divisible by itself only. Then we can say that this number 5 is a prime number. Now there is a simple observation here. So when we say that a number which completely divisible by 1 and itself is nothing but there are two factors for a number, right? Now for example, now take any prime number, n is equals to 3. So how what are the factors for it? 1 and 3. Now for example, take n is equal to 17. What are the factors for it? 1 and 17, right? Now take example, n is equals to some 11. What are the factors for it? 1 and 11, right? So can we observe something? Whenever we are taking any number, prime number, can we say that there are only two factors? Can we say that there are only two factors? Can you say that there are only two factors? For n is equals to 5, there are only two factors. So the basic simple approach, maybe the optimal approach here is that if a number has factors equal to 2, then we can say that it is a prime number, right? It is pretty much straightforward, right? So now what I can do is, so for every prime number there are only two factors, right, as you said, so that I can simply check that if count of factors, if count of factors of n equal to 2, then I can simply say that it is a prime number. It is a prime number. If count of factors is not equal to 2, then I can say that it is not a prime number, right? Print, no, it is not a prime number, right? Can you see the simple approach, right? We use the, as you said, the functions are very important. So in the previous video, if you want, you can check that count of factors if you don't know. In the previous video we have solved this count of factors, we have written in a function, right? So we can simply use that function and we can get the count of factors of n. Then what are the, if count equal to 2, then it is a prime number, else it is not a prime number, because a prime number has only two factors, right? Now let's see in the code. Okay, so basically this is my code for count of factors. If you don't understand this code, please refer to my previous video. Okay, now what I'm doing is I have taken n, right? What I will do, as we said, we'll check if count of factors equal to 2, right? If count of factors of n equal to 2, then what I have to do? I have to do just simply that system.out.println yes, it is a prime number. Got it? If it is not equal to 2, then what is simply it is system.out.println no, it is not a prime number. Got it? So let's check for some variable 1. Is 1 is a prime number? No, it is not a prime number. The starting prime number which starts is 2. Is 2 is a prime number? Yes, it is a prime number, right? Because it is having only factors of only 2 only, right? As we got here example, for example, like n is equals to some 10. How many factors are there for 10? There 1 is a factor, 2 is a factor, 5 is a factor, and 10 is a factor. So there are 4 factors, right? The count is equal to 4, but we said for a prime number the count should be only 2. So let's check for 10 also. For check, is 10 is a factor, a prime number? No, it is not a prime number because it has factors 4. The count of the factor is 4, right? Now let's check it for 17. Is it a factor? Is it a prime number? Yes, it is a prime number. Good. Now let's check for some something. Okay, I don't know. Is it a prime number? No, it is not a prime number. Let's check it for 11. Is it a prime number? Yes, it is a prime number. Now let's check it for 37. Is it a prime number or not? Let's do this. Yes, it is a prime number. So basically, actually, the approach here is itself only optimal. The time complexity will be here. The time complexity will be here only order of root n only, na? The time complexity will be order of root n only. How I can say that? Because here I am taking n, which is one iteration, which is just 1, right? Here I am checking the condition 1, right? Here we are not looping, right? But we have when I'm calling the function count of factors n, here how many times the loop is running? Here order of root n, right? Basically this is also the optimal solution if we know that count of factors. For example, see, if I solved a problem in optimal solution, then if I'm solving other problem which is connected with the first problem, then I can say that I can use the first problem optimal in the second problem, which makes easier. So, in the previous video we have learned count of factors. So basically the same count of factors we are using in the prime number. We are not doing separate thing, right? Basically everything is interconnected. So that's the reason what I'm saying is use functions and always try to understand the approach. Basically here the simplest thing is prime number in definition itself. The answer is, right, a number which completely divisible by 1 and itself. Basically it's saying that the factor is 2, then we can count the factor of 2, and if count of factor is 2 equal to 2, then we have to print yes it is a prime number, else no. And the time complexity will be order of root n, and space complexity will be order of 1, because we are not using any extra space, right? Yeah, that's it for this video. Thank you so much for watching. Goodbye.